All right, so there's 10.4. So they, is that big enough? I can make that a little bigger, huh? Okay, yeah, you want to try that? So they want the equation of that hyperbola. The game plan today is to finish hyperbola, 10.4, which will finish up all the material on exam 3, and that will be due on Monday. And then on Monday, we're gonna do the practice exam, number 3, and then Tuesday go over it. Right, I'll solve the problems on the on the overhead thing on Tuesday, and then Wednesday and Thursday. Wednesday we do part 1, and Thursday we do part 2. Well, half of Wednesday, right? For Wednesday, I'll actually lecture at first. Will I do? Is that right? Yeah. I lecture for 25 minutes on something new, 11.1. And then we'll take part 1 for the other 25 minutes, and we take part 2 on Thursday. So that's next week. So, big exam. So the practice exam is now available online for your testing pleasure. There it is. To make your weekend complete, I wanted to make sure I got practice exam number 3 up for you. So there it is. All right. So can you find the equation of that hyperbola? Now, hyperbola is very similar to ellipse. Did y'all finish your ellipse homework last night? I hope you're able to keep up. X squared over a squared minus y squared over b squared equals 1. That's the general look of hyperbola, right? It's the same as the ellipse, but has a minus in the middle. Remember that? Only difference between the ellipse and the hyperbola is the sign in the middle. Now, this picture is actually not quite like that equation. Something's reversed. What is it? Yeah, because this one goes up, down, it's supposed to be y in the front. Remember, it matters which one's in the front and the back because they're subtracted. Remember, whenever things are subtracted, the order, of course, matters. If they're added, it doesn't matter at all. So, yeah, this one's going to actually have the y in the front and the x at the back because it's going up and down. Y is up, down. So, yeah, so if it's going up, down, it's y in the front. If it's right, left, it's x in the front. Okay, so there's the basic equation. Now, how can we find, they want the a and the b, basically is what they're asking for, huh? How can we find the a and the b? Remember what the a and the b are? How wide it is, yeah. Can you tell, the box, how far right and how far left that is by the marks? Just looks like, I think this is 1, 2, 3, 4, 5, 6, right? There's invisible marks there. Right? In other words, the marks are going by 2s. Am I making any sense? The marks are 2, 4, 6, aren't they? So this looks like it's just 1 to the right. So then that would be 1 squared underneath x. And then how far up? 2. Well, that was easy. We're done. I didn't realize that was so easy. We don't even need this y equals 2x. Who cares? We don't need it. We're done. They gave me the box. That's very, very helpful. It's very nice of them. Good?
Is that how you're going to be like to us on the test?
No, mean.
Nice?
I'll be mean.
Yeah.
So 13. All right. Let me help you get started. Center, focus, vertex. And they want you to write the equation of the hyperbola. Let's give that a try. Good with those 3 dots, something like that. All right, see what you can do to come up with the equation. Which way do the branches go? Up, down, or right, left? Up, down. Everything's up, down on this one, right? And the branches always hit where? Do they hit at the vertex or the focus?
Oh,
Vertex, right? And the focus is always inside the branch, like a receiver in a satellite dish. Remember, that's how all these shapes are. The focus is always inside the branch for all of them, like that. And so the other one's up here somewhere. Whatever, I don't really care. But that's the general look on that. Yeah, Cyrus.
Are you sure the focus is inside? Because it says -9, and the vertex is -8 for y.
Right, so this is down 1, down 2, down 3, 4, 5, 6, 7, 8, down 8, and down 9's further down.
Here. Isn't the -9 outside of the -8 where the vertex would be?
So by outside or inside, I mean inside the rounded part.
Yeah.
So we can talk later. So it's going down, it's going up,
Okay.
right? Like, well, how else could it be? Like, how would the picture look?
Oh wait, never mind. I got it.
It's good? It's all good? Yeah, it's got to hit the vertex. So it's got to hit the vertex, and the focus is inside of it, so it's got to be going like that. Yeah, focus is always inside the cup, so to speak, inside the rounded part on that. So, okay, so now the equation, so the equation is going to have y in the front, so it's going to be y squared over a squared minus x squared over b squared equals 1. So the y has to be in the front, up, down in the front, y squared in the front, okay. Remember, if they're right, left, it's x in the front, okay. It's up, down, y in the front. So do we know A? So all we really got to do now is find A and B. Do we know A? Yeah, A is always, whatever's underneath y is always how far up, down, whatever, just like for the ellipse. Whatever's underneath y is up, down, x, right, left. So whatever's underneath y is up, down from the center. So how far down from here to here? Yeah, from -1 to -8. That's down 7, isn't it? It's down 7. So that's got to be 7 squared, 49, yeah. Good so far? Up, down? To the vertex, right? Okay, now, what's the B? How do we find the B? That's how far right and left, but this time they're not giving me the dotted box. So I don't know how far right, left. Whatever's right, left is always what's underneath X, huh? I don't know that. What can I do? Yeah, good job. Exactly. The focus equation, huh? Like we always use, don't we? Because we do know how far to the focus. Exactly right. So I'm just going to do it up here. Got a little bit of room. So yeah, the a squared. Now remember, for the focus equation, the rule is for both ellipse and hyperbola, whatever sign is in your main equation, it's the opposite in the focus equation. So it'll be plus in the focus equation like that. And which is nice. That way we don't have to worry about the order, right? Because they're just added, so who cares which one's A and B? Doesn't matter to us at all. So I'll just say 7 squared plus B squared. Now, do I know C? C is always the focus. Do I know C? How far from the center to the focus point? How far from -1 to -9? -8. This is 8 squared, huh? Remember, C is always how far to the focus? From the center. So that'd be 49 plus B squared is 64. Subtract 49, is that 15? So B squared is 15. I don't even need to go on and find B, which would be the root of 15, because I want B squared anyway. B squared is 15. B's the root of it. If that bugs you, you can write it as the root of 15 squared, because that's what B is, right? B is the root of 15, which is just 15, either way. You can write that as root of 15 squared, or you can just say, or it's 15.
Wouldn't the 8 be 9?
Wouldn't the 8 be 9?
Yeah, for the focus.
So from -1, it's from the center.
Oh.
Yeah, it's from the center. Yeah, it's always from the center. The center's at -1. -1 down to -9's 8.
So the form will be -1, the difference of -9, and that will become 8.
Yeah. How far from -1 to -9? Yeah, the difference. Yeah, if you want to be formal about it, it would be -1 minus -9. Yeah, plus 9, 8. Yeah. Or the other way. You can subtract the other way. You get -8. Either way, it's going to be 8. Yeah, we know from -1 to -9 is 8. And we got it. We good? I'll move on. Okay, so they're giving me a couple vertices and then an asymptote line equation. Yeah, let's try that. Okay. So here we go. Let's put the dots on there. So they're all down 5. So back 4 down 5 like here. Back 4 down 5. Over 8 down 5. So I got those 2 dots. Like that. Those are the 2 vertices. And the focus, oh, no, don't give me the focus. Okay, so are the branches right, left, or up, down? They're clearly right, left, huh? So we got a branch going like that, and we got a branch going like that. Good so far, branches right, left. Now, so that means in our equation, it's x squared first, when it comes to writing the equation, because it's right, left branches instead of up, down branches. Good so far. Now, what can we do next? Do you know, what is the center on this one?
We add the x's and then we divide by 2, right?
Do you know the center on this one? Yeah, we could do that. Let me give you a hint.
The midpoint?
The asymptote equation, those guys are telling you the center. Because you do with the asymptote equation the same center thing you do with the main equation, which means what? X minus 2, y plus 5. That literally means this is x minus 2 squared, and this is y plus 5 squared. Does that make sense? What's in the asymptote equation is literally, so yeah, but the other way could have worked too. What Raul is saying is right too. We could have just found the center of these vertices by taking the what? The back 4 and the over 8 and averaging them. Remember how to find the middle of two things is to add them and divide by 2, the average. So minus 4 plus 8 over 2 is 4 over 2, 2. So that would be over 2 down 5. That's what we found here. Negative 2, positive 5, opposite, opposite, huh? Same truth either way. So we had 2 ways of finding that. Okay. That's the center. So we've got our equation, opposite, opposite, which really we could have just grabbed right from the asymptote. Okay, so now can I find, all I got left is to find A and B. A and B, you know, what's under X is how far right, left. What's under Y is how far up, down. Do I know any of those immediately from the picture? How far right? From 2 to 8. 2 to 8? 6. So what's under X, what's under right, left is 6. From the center to the edge is 6. This is plus 6. So now how do I find B? No, this time, this is the one time I'm not going to use that. Because I don't know C. I don't know anything about where the focus point is. So what am I going to do? Beautiful. There it is right there. Remember what that is in the asymptote equation. Remember when we talked about this yesterday with the asymptote equation? You couldn't think about anything else all day, right? It's just like asymptote equations are rise over run. It was in your mind all day long. Of course it's rise over run. I should have thought of that. It's rise over run, right? Remember, because it's a slope, it's a line.
So we didn't have to do any of that work?
Really, yeah. Rise and run are 7 and 6. This is 7. Right? 7 is what's under Y, it's rise. 6 what's under X, it's run. Done.
There's going to be a lot of those on the test, right?
There'll certainly be one. I don't know if it'll be exactly like that. But is that good? There we go. So never, we didn't use the focus equation. We didn't even know where the focus was. All right. Give it a go. What do you got to do on that one to graph it and find everything in the world? You got to give it the right look, huh? Right? You got to make it have the x minus some number squared over some number squared minus y minus some number squared over some number squared. And you got to transform it to have that look, and then you can graph it and find everything they want you to find. Huh? All right, so give that a try. I think you'll get more out of it if you do it first rather than me just dive right in. All right, so how you doing? First, you got to put all the x stuff together, and then the y stuff, and move the minus 25 to the other side. We good there like that? Remember that? Remember, you got to complete the square. You got to make them factor as a square, huh?
Oh shoot, we gotta factor the negative.
Yeah, good, Barbara. You
I
need
was
to do
like,
that.
it's not canceling.
Exactly. So you got to take the mid. Remember, it's always the middle number over 2 squared.
Plus 2.
36. Good. Middle number over 2 squared. So 36. Is that good? It's always positive, isn't it? Right. The completing number is always positive because it comes from squaring. Right. So add 36 to one side. Of course, you got to add 36 to the other. Good to there. Now the y is the real trick. Let me let you do the y. Have you finished the y? Let me give you a second. The y, you will get much more out of this if you do it right now and do it wrong, because there's a trick there. You'll learn much more if you do it now and do it wrong, rather than if I just go blah 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 blah, do this blah blah blah. You won't realize that I'm saying a big deal trick that fools a ton of people. So give it a try yourself first. See the trick. If you're just adding 25 to both sides, you've fallen into the trap. You do not add 25 to both sides. That's wrong. Because there's a negative. Exactly. Remember, when there's anything in front of the x squared or y squared, even a little bitty negative sign, you must factor it out. Remember when we talked about that? You guys never forget anything we do in here, right?
Never.
Got to factor out. Yeah, you have to first factor out that minus, and that changes the other sign. Right? You can't only if there's a plus in the front do you not factor. If there's a number, remember we had like 4 on it, or we had some number the other day, yesterday or day before, right? If you have a number in front of y squared or x squared, you know you need to factor that out first. Well, the same goes for a negative sign. You got to do this first, and it changes that sign, right? If I was to distribute that, it would go right back to negative y squared minus 10y. It's the same thing, just with the minus 1 or just minus whatever factored out. Right? Okay, you might be thinking, what's the big deal, Mr. It's still going to be 25. Yeah, but careful. Take the 10, put it over 2, square it, 5 squared, 25, positive 25. I agree, but positive, let me do a different color so you remember it. Positive 25, put right there. That part's true. Positive 25 on that side, yes. But what did I, by putting a positive 25 in those parentheses under the influence of a minus sign, what did I really do to the left side of the equal sign? Negative 25, and I've got to really do that to the right side. Do you see the trick? That's really subtracting 25, because that 25 is under the influence of a minus sign. Right? If I was to distribute this, that would be a brand spanking new negative 25. That was never there before. So I really affected the left side by negative 25. I've got to really affect the right side by negative 25 as well. So that's what we do. So now these guys will factor, won't they? Can you factor both of them? So it'll factor as the same thing squared. Right? Let me get rid of this. So what do we got? We got minus. So then factor this left side. What do we got? This is x minus 6 squared minus y minus 5 squared. Everybody see that? No, plus 5. Plus 5 squared, huh? The sign in the middle will always go in the parentheses, if that helps you. Equals, these guys cancel, 36. Is that good? It's always good when a really clean number is over here, huh? That's reassuring. If you'd added the 25, you would have had like 116 or something. That's not a nice number. It's a good sign something's wrong. All right, so then divide through. We got to get a 1. So divide through by 36. Always got to get a 1. So we have x minus 6 squared over 6 squared minus y plus 5 squared over 6 squared equals 1. There we go. Now we're getting close. Now, can we do the rest of the problem?
Center is.
So I'll put it on a fresh screen here. This is number 19. What was it? X minus 6 squared over 6 squared. Plus 5 squared over 6 squared. Okay. Yeah, now we can graph. So, where's the graph?
Center.
Over 6 down 5. Right? Because center is going to be 6, opposite, right? Over 6 down 5. That's the center. Opposite. Okay, and then from that center, now the branch is going to be up, down, or right, left? Yeah, X is in the front. So the branches are right, left. How far right and left do we go to the branches? Yeah, it's whatever number's here. Right, left, 6. So go right 6, left 6, and there'll be a branch. A branch. Good? To there. So I'm supposed to draw the dotted box, and yeah, maybe I better do that. I'm being kind of lazy. So I should draw that. Yeah, I don't really want to. You're supposed to draw, and it's supposed to go up and down 6 as well. Up, down 6 also. So it's going to be a square, isn't it? It's going to be a 6 by 6 square. You with me? So then you put in the diagonals, you know, da-da-da-da-da. And those are the branches. Those tell you how wide to make the branches. Those diagonal asymptotes, they hold the branches, don't they? Bless you. Right? You guys with me? Am I doing this too casual? Look back to last time if you're confused by what I'm doing. So you make the box. The box is right and left 6 and up and down, just like you would for an ellipse, right? Whatever numbers are underneath X is right, left. Whatever numbers underneath Y is up and down. So you go right and left 6, up and down 6, but instead of making an oval with those 4 points, when you go up 6, down 6, right 6, left 6, you make a dotted box. And you fill in the diagonals with dotted lines. Those are your asymptote lines. Those hold the branches. They tell you how wide to make the branches, right? So once you make that dotted box, then you actually start right in the middle, and the branch comes up to that dotted line and down to that one. Same thing on the other side, up to that one, down to that one is what it should actually do. Is that good? Tells you how wide the branches open. That's what those diagonal dotted asymptote lines do. All right. So now they want everything in the world. They want the vertices. What are the vertices? That's here and here. These are the two vertices. So what are they? From the center, which is 6 minus 5, the vertices are right and left 6, aren't they? So if you take the center, 6 minus 5, and you add 6 and subtract 6 from the x-coordinate, you'll get the vertices, which are what? 12, negative 5, and 0, negative 5. Everybody with me on that? See what I'm doing? So I took the center, opposite, 6, negative 5, and I know it's left 6, right 6. How do I know? Because that's what's under x. Left 6, right 6. So I added 6 and subtracted 6 to the x-coordinate of the center. Got the two vertices. Let's find the foci points. How do we find the foci? Foci will be inside the branch, won't they? How far? We use the Foci equation, which is a squared plus b squared is c squared. That's where you'll find the two foci. Right? Remember, whatever sign is in the main equation, negative in the main, we use plus in the foci. It's always opposite, isn't it? So, all right. So a squared and b squared, that's 6 squared and 6 squared, isn't it? That's 36 and 36, 72. C squared, so root it. So that's 6 root 2. If you simplify that, 6 root 2. So the foci are left 6 root 2 and right 6 root 2. Left and right 6 root 2 from the center. Good there. So let's go back, if I can erase this and find that then. Left and right 6 root 2 from the center. So I take that center now and I add 6 root 2 and subtract 6 root 2. So the foci points are what? 6 plus 6 root 2 minus 5 and 6 minus 6 root 2 minus 5. So we got the two foci. Am I losing you? Questions I can answer to that point? Is that okay? And we're going to find the asymptote lines, but am I okay? I kind of made a big mess out of this one. I went quick. If this is confusing, look, I went slower yesterday on the first lecture on this, and I showed the dotted box more carefully and the asymptote lines more slowly. So, but again, basically the dotted box is just up 6, down 6, right 6, left 6. Make a dotted box. Now, for the asymptote lines, last thing for us to figure out, the asymptotes. What's the equation for the asymptotes? How do we always do it? It's always y equals rise over run x. It's just slope times x, mx. Yeah, we'll do all that in a minute. But generally, it's rise over run. Rise over run, right? So here's the center, which is not 0, 0. We'll get to that in a minute. But let's just focus on rise and run for a minute. It rises 6, it runs 6. Remember, the box went up 6 and right 6. They're both 6. Remember, whatever's underneath y, that's rise. That's up. Whatever's underneath x, that's run. That's sideways, isn't it? So that's 6 over 6x. That's just 1x. Plus or minus what? Because one goes up, one goes down. There's two asymptote lines, right? One's going up to the right, the other's going down to the right. So it's plus or minus 1x, except it's not really centered at the origin. That's the right slope, plus or minus 1, because it's rise, run, 6 over 6. But what? It's not centered at the origin, right? Where's it centered? 6, negative 5. What does that do? Exactly what moving the center always does in any shape since the very beginning of this course. I do opposite, opposite. Instead of y, I go y. Y is negative 5, x is 6. So I go y plus 5 equals, then plus or minus 1 times x minus 6. See, it's just opposite, x minus 6, opposite of minus 5, plus 5. That's a parenthesis. You don't need the parentheses. I'll just say y plus 5 there. Okay, let me rewrite that. Get it kind of sloppy. So y plus 5 is plus or minus 1, x minus 6. Does that make sense on that? You just pop in the center. You just do the work first, rise over run, 6 over 6, 1, plus or minus for 1 up, 1 down, and then you put in the fact that the center is not 0, 0. It's 6, negative 5, so minus 6 plus 5. And there we go. We did like everything on that one.
That was.
Hours of your life, isn't it?
No, not hours, years.
Oh, they want the transverse axis. Yeah, what's the transverse axis? Oh, do they?
The one where
Do they really? What's the transverse axis? Careful. What is it? It's not x.
It's y?
It's not y.
It's neither.
That's why I said careful. When I say careful, it can't be obvious, right?
It's y divided by x?
Isn't this it right here?
Yeah.
Yeah.
Oh, let's do the vertices. I get it. It's just parallel. It's just
Oh, does it? Okay, good. So they just want x then. Oh, yeah, so they'll be happy with x. They're saying the parallel. This is really the transverse axis right here, which is parallel to the x. Yeah. So they're just wanting what it's parallel to. So yeah, x is good. I thought, wow, I don't remember them pushing that hard. So, there we go. Was that fun?
That was really fun. Let's do it again.
All right, let's. All right, so there we go. So try that completing the square thing. So you got to reorganize things, right? Put the X stuff with the X stuff and the Y stuff with the Y stuff. And push the 225 to the other side like that. And then you got to factor out, don't you? What's in front of the X squared and what's in front of the Y squared?
You put a square on the 10y.
Oh, thanks. Good to there. Remember, when you factor that negative out of the y squared, it changes the signs inside, huh? So find the middle number. Use the middle number to find the completing number. You guys finding those completing numbers? Take the middle. Over 2 squared. 5 squared. 25. Add 25, but when you add 25, it's really under the influence of a 9. So you got to actually add 9 times 25. 9 quarters, $2.25, right? To that side. That's convenient. That cancels the other 225, huh? And now do the y. Take the middle number. Over 2 squared minus 5 squared positive 25. But what am I really doing to the left side when that's under the influence of a negative? Negative 25. So oh yeah, this is a good one. Oh, I'm glad we did this one. Yeah, I got to remember, 21's a good one to do. I'll do it with the other group too. This one has a nice little trick at the end. Yeah, good. Okay. So negative 25, which is weird because the right side's negative. That's the trick we're going to see. So good so far?
Yeah.
Everybody good? These cancel. Right side's negative 25, which is weird. We'll talk about it. Everybody good to there? Okay, now factor. Those completing numbers are meant to complete them so that they now factor. And they will. How so? This is x plus 5 squared. This is y minus 5 squared. Is that good to there? My daughter was just showing me last night. She's taking a calculus class up at Clovis Community College, and she had they're doing a big 3-dimensional kind of thing, and they were doing this exact kind of thing, completing the square. She had x, y, and z. It was three-dimensional, and she just made one tiny mistake on one of the, just got her test back, and she was completing the square, and instead of writing 25 here, she was thinking about the fact that it was going to become 5. She was kind of thinking in advance and just put a 5 there. But she actually knew it was 25 and calculated the number on the right side and all the rest of the numbers. And the final answer was correct because she did the right thing. She just accidentally wrote a 5 here, but fixed it later and made it all work. And he went there and circled it and said -2 points, even though the final answer was correct. Just writing that. So just letting you know, this doesn't go away. She was not happy about that. And I was like, honey, welcome to higher math. They care about every step being logically correct. That was a little rough. So you could have meaner teachers than me. She had the final answer perfect, but just along the way, one little mistake. So anyway, this doesn't go. If you're going to go into higher math, it's completing the square things around all the time. All right. So what do we do now? What do we do with the right side? We always just divide by, right? Divide by -25. Got to make that a 1. Divide by -25. Divide by -25. All the way across. That produces 1. No big surprise here. Now, oh yeah, there's a couple weird things. Oh, I'm glad we did this one. Definitely got to do number 21. All right, let's go to a fresh screen and take a look at what we got here. This is number 21. It's a good one to finish up with. 9, okay. Is it x plus 5? Yeah, x plus 5 squared over -25. Minus y minus 5 squared over -25 equals 1. All right, number 21. Are we good to there? So now, I'll write myself a note to do number 21. Glad we chose it. I'm glad you chose it, Barbara. Did you choose it? All right. So now, what? This looks weird. Isn't this weird looking? Now remember the look. This is some fancy plastic surgery. This is some big wrinkles we got to remove here. So remember the look we want. Don't we want like something down there and something down there and a 1? Like we don't like a 9 up there, for example. And what's with the negatives? 2 weird things about this one, right? And we've got to somehow change the look without changing the value to look like this. We don't want numbers in the top. That's not the look we want. We need numbers in the bottom only, because that tells us how far right, left, and up, down. Right? Under x, right, left, y, up, down, right? I can't have numbers in the top. So how do you do that? Well, let me not answer that question for a minute, let you think on that. But let's do the negative thing first, because we also have a problem with the negative thing. What do you do about the negative? Negatives in the bottom of a fraction can come to the front, can't they? And then 2 negatives here, positive. That's what we do with the negative thing. Comes out here, negative. We good so far? Everybody, so they're going to switch roles. The y is going to go to the front. Do you see how the negatives in the, remember, negative in the bottom fraction, you just put that in the front.
I see.
Right? So then the y is actually going to go to the front. He's the positive one. And the x to the back. Do you see what happened with those negatives in the bottom? They changed the signs on both those guys, meaning they switched who's in front. So good with the negative trick? Now, what about that 9? We can't have numbers in the top like that. That's not the look we want. We need only bottom so we know how far to right, left, up, down thing. Well, what are you doing? There is a 9. I mean, how do I not have a 9? How can I write something in the bottom only, and it really be the same as a 9 in the top and a 25 on the bottom? Flipped. Exactly. Good job. 25 over 9. That's the same thing. That flips up and is 9 over 25, isn't it? That's a different way to say the same thing. Everybody see that trick? Am I losing you? Remember the high diver trick? Fraction in the bottom of fraction. You could always flip it up, and it would be 25 over 9, wouldn't it? It's the same thing. And now we can graph. What do I mean graph? Well, this is 5 squared. What is this? You might think, what is that? 5/3 squared. So we can. That's a distance. 5/3, 1 2/3. Right? That's what you need to do. You see that trick? So in other words, this graph will be right and left. This is right, left. Right, left, 5/3, up, down, 5 from the center, which is -5, -5, and don't have time to do the rest. Does that make sense? So that was a tricky one. This is not for the casual math student, right? This is for those who are committed to give their life to it.
I'm committed.
We'll see. We will see.